Quantum computers are becoming more and more powerful, and at the same time, the algorithms that can be run on those become more and more resource efficient. So quantum computing is moving from a textbook case towards something that might actually make its way into useful applications. And people are debating about the time frame that it will take, if it's like 2 years or 5 years or 10 years or 15 years from now. And to be honest, we don't really know about that, but there are certain threats that if they become at some point, even in 15 years from now, a thing, we already need to start triggering actions today. Quantum encryption is one of them because of the so-called harvest now, decrypt later scheme. And if you actually want to know how companies are already today working on solutions to that, on the hardware side that can be introduced in today's products to make them safer for the future of cryptography, then today's video is exactly right for you, because we are looking into a company called Quside that is making quantum random number generators. These are useful for cryptography, but also for other things like, for example, Monte Carlo simulation and exploration or heuristic exploration type of algorithms. And if you are interested in any of those topics, or if you're looking into companies that make random number generators, then stay tuned for today's video as we are diving deeper into Quside. And with that, let's hop right onto their website. Here we are. It says Quside, and then the foundation of digital trust starts with love. And before we go into this, I would like to ask you to make sure that if you're liking these type of videos where we are diving deeper into companies and looking into their products and how they are actually changing maybe the markets today, but potentially also the future, then please make sure to like this video so that we can produce other videos and that the algorithm is pushing those videos out to other people that are interested in this as well. If you know somebody that is interested in it, please also make sure to share it with your friends. Now, we really want to dive now into this company, so let's start right away. Here we are on their website, right? And what do we see? So first of all, there is this report here, and I guess it's an interesting one. It says a year of impact Quside on the world stage. And there's a lot of information about what the company did in 2025. So if you are interested in that, I encourage you to check it out. There's much more information in this than what I'm going to discuss in today's video. So we developed quantum technologies for secure connectivity and efficient computation. What does it mean? We see right here. So there are solutions in the cybersecurity space. So we see those right here. It goes from the chip side. So you see here there's the Quside Ruby S1 quantum random number generator security chipset and the Quside Ruby N1 quantum random number generator security chipset. But it also comes in a card format. We see here a PCIe form factor and then here an FMC module. If you are working in the compute space and integrating hardware into, for example, servers, then you know what this is about and what it means and where to integrate it. We also see the entropy core. So that says for a stronger cryptographic foundation in your enterprise application network. This is like a server rack size of system. So this is a fully integrated system, I assume, that is interesting for people that are working on the rack size of computers. So like telecommunication providers, network centers, things like this, or computing centers. And then finally, we see here also on the computing side, a let's say bigger PCIe form factor, at least it seems like that. So here it says 10 gigabytes per second performance for accelerated randomized workloads. So this is probably for people that want to use that for heavy types of simulation. And then we see the RPU cloud with up to 60 gigabytes per second performance for accelerated randomized workloads. So this is then probably a cloud access where you can API request those random numbers. Probably they host in their cloud a couple of these to kind of enable this. But we will learn about that more as we move on in today's video. So the level of trust you need. For over a decade, we redefined our quantum random number technology to generate random numbers that not only meet the stringent SP800 90B certification standards set by NIST. NIST is the National Institution for Standardization, I think, in the US. So they are basically the institution when it comes to standards like cryptography standards. And they have announced that, okay, over the next couple of years, and I've talked in a different video about what timescale they are looking at. So if you haven't seen it, make sure to check out the Hidden Quantum Champions playlist. If over the next couple of years, the quantum computers become more and more relevant, we need to change the way that we are doing random number generation and cryptography. And basically this certification here, or this standard, is actually referring to that. But are also observable, making them the most secure, efficient, and reliable option on the market. So that's just from the text, right? And we see some cool random number animation over here with the zeros and ones coming out of this chip. And then it says we built something small enough to solve a problem big enough. That, I think, refers to the chip solution, right? So future-proof, accelerated, entropy-rich, and measurable. Future-proof means make your products and services flexible and upgradable with the strongest cryptographic foundation. Accelerated means speed up randomized workloads with a hardware platform designed specially for the task. Entropy-rich, make entropy starvation a thing of the past. So quantum hardware delivers always on, always fresh entropy fast. Entropy as in randomness, right? And then measure the unpredictable. Quantum is the only technology that allows you to check random numbers. Okay, and then we see here some basically partners they work together with. A couple of them we've also featured already. So you see Crypt with a Q, you see Lux Quanta and other ones. They are also known companies like EY listed in here, and so on and so forth. I'm not going to go through all of these. We also see Telefonica here with a case study, I guess. It says that Telefonica, which is the Spanish telecom provider, we persistently evolve our understanding of the future of the future to transform it into reality. The quantum-safe developments will enable Telefonica and its customers to benefit from enhanced security with easier deployment. End users will also again form the assurance of uninterrupted services and protect against advanced cyber threats during the whole device's lifetime. And there are also other ones mentioned over here. Then our technology in action. I guess these are, let's say, the case studies here where we can learn more about how this technology is actually being used inside customer organizations and then stay up to date with the latest news. I'm recording this April of 2026. We see the last one mentioned here is from 2025, but also before we saw the whole report on 2025, so that would be end of 2025. So let's say not fully up to date, or maybe there's not too much new happening, I don't know. But at least some stuff is coming here, right? It's not like they're completely out and nothing's happening. Then we see down here in this banner a couple of other trusted partners, right? So you see here the European Union, you see the Quantum Flagship, and other ones mentioned in there as well. Now, let's quickly check out the products that we've seen already before. So you see these different form factors and cards and the chips. There's another one here, which is called the Quside Entropy Core through Equinix Fabric. And then there's more over here with the cloud and so on. Let's quickly check out the chip, because I guess that's the very fundament. There are two different ones here. There's the N1 and the S1. Let's quickly check out the N1. I guess they both rely on the same technology. The difference we see down here in the fine print. So one performs at 50 megabit per second, and the other one is 1 gigabit per second performance. So let's quickly check out the N1, which is the one with the gigabit performance. So The Quside Ruby N1 is a SP890B certified quantum random number chip, that random number generator chip that provides fast, scalable, and unpredictable randomness. The Quside Ruby N1 enables 1 gigabit per second quantum entropy generation on a single 5 by 5 millimeter footprint, making it the fastest quantum entropy chip on the market. Based on phase diffusion technology, the Quside Ruby N1 brings a decade of research and development into a large-scale manufacturable semiconductor chip. Fully compliant with the rigorous SP890B certification standard set by NIST, the Quside Ruby N1 is the first of its kind and takes security, privacy, and efficiency in randomized computation to a whole new level. Here we can also compare both of those chips. Let's maybe not do that for now, but look at the N1. It says, okay, performance we've seen, certification, yes, observable entropy, reliable, so 95% min entropy bounds to guaranteed unpredictability, and then unique, so cutting edge photonic chip implementing the phase diffusion quantum entropy generation technology. So it uses photonic technology and then this phase diffusion, which I think has something to do with the optical phase, basically, to generate this randomness. It consumes only 0.3 watts at operation, and it generates this 1 gigabit per second of data, randomized data. And then on the raw statistics here, it says 0.01 bits per max 0.02 bits. Then also here on the single bit conditional min entropy, it's 99, so 0.99 plus, and conditional min entropy rate at 0.9 at 25 Celsius, I guess stable temperature condition. There's also a data sheet here. So yeah, that's basically about the chip. There's also other products, I've mentioned them before, but let's talk about where this actually plays a role. So why should anybody be interested in that? Who should be interested in that? Here you see the target sectors. So we see finance, government and space, telco and data center, and logistics and retail. We've talked about a couple, or I've talked about a couple of the use cases before, right? So there is the whole topic of encryption, and I guess that plays a role in finance, that plays a role in telco. We've actually read that it plays a role in telco and probably also in government. There's also the simulation space of so-called Monte Carlo simulations, which probably also goes into finance, but then also into the logistics related topics and in data centers and so on. We see also down here, so we have the cryptography, the Monte Carlo method for simulation, and the heuristic optimization. Probably that's even more interesting for the logistics part. Heuristic algorithms are what we use for navigation today, because it is very complex to actually find the optimal route between 2 points as the number of points, let's say, increases in the network. So think about your navigation system in your car. When you want to navigate from, let's say, Paris to Berlin, there's a certain distance. There are many different streets that you can take, many different highways that you could be taking. So you could go down to Rome and then go up to Berlin. But you could also find a route via, I don't know, Hamburg in Germany and then go to Berlin or something else, right? There are many, many different ways, and there are many different knots in this network connection. And actually finding the optimal connection between those two, so the fastest connection, is something that is increasingly complex as you add more points to this. And if you do like a round trip, this is called the traveling salesman problem. You can also look this up. So if you're trying to visit, I don't know, Paris, Hamburg, Berlin, and Rome, and you want to do a round trip, there's one combination where it's the fastest connection, but there are many different connections possible. So you could also go in a zigzag motion, right? But this is just much longer. And finding this optimal connection becomes more and more difficult as you increase the number of knots, of points in your system. And this is usually solved not in the perfect, but in a local optimum. So in something that is close to the global optimum of a solution, so close to the fastest, but not necessarily the fastest solution, by so-called heuristic optimization, heuristic algorithms, and that's what is mentioned here. So for that you also need an element of randomness, and that is basically where these chips become interesting. Okay, so maybe let's quickly hop into, let's take telecom and data centers for today and look into what solutions we can find here. So reinforce your telecom cybersecurity with quantum technology. So that's the cybersecurity aspect. The most out of your infrastructure with our telecom cybersecurity. Enjoy secure connectivity, reliable processing, complete visibility, and optimum performance, which leads to better decisions made faster, reliably monitored, and a lifetime of security. So better decisions as in optimize your infrastructure by accelerating randomized workloads with up to 10 times performance upgrades and 20 times lower energy footprints. Reliable monitored, so provide the most advanced infrastructure monitoring with full observability for the strongest telecommunication security, guarantees infrastructure control and performance vigilance, and then lifetime of security. It says our flexible, upgradable infrastructure protects your investment with quantum-resistant, crypto-agile, and hybrid cryptographic practices. Finally, you find some points here on the application. So enhanced infrastructure, entropy as a service, RPU as a service, managed services, and SDWAN. So enhanced infrastructure, protect infrastructure with fast and measurable quantum entropy. We've talked about that. Entropy as a service, let customers access additional entropy compliant with NIST. So that can also be a business model, right? You host one of these servers in your data center, and then customers can actually use that to retrieve random numbers for their applications. Then RPU as a service, so broaden heterogeneous compute offerings for financial services and insurance customers. So that's, I think, one level up in the value chain. So build applications on top of that, right? Managed services, so enhance your managed services portfolio by monitoring cryptography's core material entropy. And then finally the SDWAN, bolster software-defined network security by deploying advanced security functions. And then finally you find the elements, so the products down here and the cases down here. So using an RPU to improve MIMO decoding for 5G technologies, and then Telefonica Tech collaborates with Quside and Qript to validate quantum technology, and then we see those mentions down here. Now let's quickly pick one of them. Let's take the Telefonica one. Telefonica Tech collaborates with Quside and Qript to validate quantum technology. So Telefonica's digital business holding company is offering its customers next generation solutions in its VDC cloud service following successful completion of testing. Quantum random number generation and entropy as a service, EAAS, architectures have facilitated this advanced offering and the validation of an extensive number of use cases, including enhanced key generation for cryptographic modules, HSM, data security in SDN networks, Monte Carlo simulations, and randomization for gaming applications. Telefonica's Tech VDC's customers will benefit from the quantum random number service, and the technology will be accessible as a new resource in the cloud. So basically on Telefonica Cloud, you can now access those devices for your end applications, basically since 2021, as it mentions over here. Here you also see how this is being set up. So you have the Qript appliance with Quside in it. Then you have this API connection here, which connects to the cloud, and then the API connection of the cloud to the customers and customer devices, where they can then retrieve those random numbers via this service. Because we have seen the Qript in here, there's also, I think, an episode on this company in the Hidden Quantum Champions playlist. Make sure to check it out. But what it says down here, just as a reference, right? Based in New York City, Crypt's quantum hardware and post-quantum software solution offers organizations all-in-one protection from threats today and those on the horizon. More information on their website. Okay, now let me quickly also check the other solution that I wanted to show you for financial services. So in the financial and banking space, deploy the strongest foundation for trust and data security financial services. So this is now building, this could be, for example, one customer of also this cloud offering, right? So where is it actually useful? It's useful in risk assessment, fraud detection, high frequency trading, portfolio optimization, and pricing. So it's all in the, let's say, statistics-based mathematics space. Risk assessment, improve accuracy by producing software distributions in VAR, ES, and more. Fraud detection, streamline AI model training with faster synthetic data generation methods. High frequency trading, get an edge over the competition by leveraging Quside's low latency optimizers. Portfolio optimization, accelerate advanced optimization techniques with randomized workloads. And then pricing, boost return on invest by accelerating pricing calculations. Here you also see some examples by the Barcelona Supercomputing Center and the CESGA, which deploys Quside random number generators into their data center to offer increased capability stochastic workloads. And then here I think are also some partner quotations down here. Now I don't want to make it too long. Also there are already some videos about quantum random number generators within this playlist of the hidden quantum champions. But let's quickly also check out about the company itself. So it says we are building the strongest randomness foundation for everyone everywhere. We believe advances in technology create new capabilities that can transform the way billions of people communicate and compute. Our mission is to research, engineer, and integrate quantum technology that ultimately leads to more secure connectivity and efficient computation for everyone. And then here we see, I guess, the core values: care to build, build with care, and for everyone everywhere. I think we've basically seen the for everyone everywhere, and probably also the other one in the mission statement up above. So we strongly believe that strong cryptographic solutions and more efficient computing platforms are challenges worth investing in, even when it isn't the easiest thing to do. We contribute by developing the most advanced randomness solutions to security and computing performance. Build with care, the invest talent, resources, and time to build products with the highest scientific caliber and engineering excellence. Our solutions have been used in the most remote and challenging scientific environments, but it doesn't stop there. We apply our excellence criteria to everything we do. And then for everyone everywhere, we build advanced technologies to address global challenges. We know it is only worthwhile if we make them inclusive and available for everyone everywhere. That's why we have dedicated ourselves to making our products easily scalable. We make it small enough to solve a problem big enough. On the company story, so we are ready to take you further faster. Over 6 years ago, we were a little startup conducting forward R&D at the Institute of Photonic Sciences in Barcelona. We have launched our first product at high quality quantum random number generator. We realized we were onto something big. In 2017, we launched Quside with the mission to deliver safer connectivity and efficient computation for everyone everywhere. We wanted to know what people were looking for in their technology, so we built a network. We engaged in several activities to spread the word about quantum and became an active member of the European Quantum Community and the Quantum Industry Consortium, QUIC. We also serve as a key contributor in a variety of projects for the European Commission, Orange and Civic, projects for the Quantum Flagship Program, and national efforts, which is CLAVE, CARA-MUL, and QSPIN. Since then, we've expanded our portfolio and we are ready to show what we can do. We've developed technology to improve current solutions such as key generation and Monte Carlo simulations. We are looking ahead. now we are looking ahead. We strive to find new ways to do what was once considered impossible to take you further faster. And then here we see the team, and it's actually quite big team. So we see the co-founders and basically the C-level here, but there are also all the other functions in a company that you need, like product management, finance, operations. I think there's also some HR in here, marketing. So of course a lot of engineers and technical people as well. So you see it's a quite broad team that we have here. Finally, there's a call to action to join them and a little note on the partners that we've seen before. Also, there's some news section down here and some way to get in touch with the company. With that, as per usual, we are at the end of today's video. I hope you liked it. Thanks for all the patience and staying all the way to the end. If you have not subscribed to this channel yet, please make sure to do so you don't miss out on the next video. As always, stay hydrated and see you in the next one. Bye-bye.